This is a lesson on linear equation. So just to give you like an overview, most of it's, or well, the first part of it is like just recap on what we've done last year, just normal linear equations. And then also these, A and B is also basically just last year's work, but C incorporates like the products that we've learned about how to multiply binomials by binomials, and then we look at linear equations with fractions, and then again with fractions, but then when we have the variable in the denominator. Okay, so first of all, just to quickly recap, when we solve linear equations, we take all the variables to the one side. Now be careful for the signs. There's a negative in front of the 6, so that's just a common mistake. So keep that sign there, and then we just take the constant over to the other side. So this would be then negative 9. Changing the sign when you take it to the other side. So now adding the like terms, we've got negative 6x equals to 18, and then we want to get rid of that negative 6. So we divide both sides by negative 6, and x is then equal to negative 3. And then for b, we've got 5x on the left-hand side, bringing the 6 over, gives us negative 6x minus 3 minus 7. When we take the constant to the right-hand side, here we have negative x equals to negative 10, so x is equal to 10. Okay, now when we have brackets, we obviously just first need to multiply out the brackets. So for a, we have 6 plus 3x minus 6 equals to 4x plus 4. And then we will just follow the same procedure, like we take all the variables to the left hand side. So we've got 3x minus 4x equals to 4 plus 6 minus 6. So this is going to be negative x equals to 4. So x is equal to negative 4. And then for b, just do b here, multiplying the negative. So when we multiply in the negative, the signs basically just change. So plus 4 equals to 2 minus 5x. Take the x's to the one side, so plus 5x equals to 2 minus 4, constant to the other side. Then we add the like terms. So we've got 2x plus 5x, that's 7x, equals to negative 2, and then divide both sides by 7, so x is equal to negative 2 over 7. Okay, and then when we have where we have products like squares, bracket squared, so just a note, like you can choose to expand x minus 1 and FOIL it out, or like that, and then just multiply it out. I'm just going to apply the quick way where we square the first term, so I still have that 2. Square the first term, multiply them with each other, multiply by 2, so it's minus x, multiply by 2 is minus 2x, and then square the last one. So when you square a negative number, it always becomes positive, plus 1. Okay, and then those two we can multiply out. We've got 2x multiplied by x and then by 1, so we've got 2x squared plus 2x, and then let me just erase that. Okay, and then the negative 3, so minus 3x minus 3. Okay, so we still need to multiply this 2 into this bracket. 2x squared minus 4x plus 2 equals to 2x squared plus 2x minus 3x. We could have added like those so long, but either way, now these two, since, well, if they didn't cancel out, we'd no longer have a linear equation, but they do. So 2x, if I bring all the x's to the one side, this 2x squared goes over to the other side and it becomes 2x squared minus 2x squared. So that would just become 0. Okay, so we can continue taking all our x's to the one side. So minus 2x plus 3x equals to negative 3 on the right hand side minus 2. Then minus 6 plus 3 is minus 3x equals to negative 5. And then divide both sides by negative 3. X is equal to, well, that would just end up to be 5 over 3. All right, so that's just our normal linear equation. So if we look at ones with fractions, what you want to do is you want to get all the terms over the same denominator. So as I said in class, like there's two ways. You could either start by multiplying out. So if I go, let me just do this, that's going to be too light. So if I go and I say, okay, what's the lowest common denominator between 2 and 5? We know that it is going to be 10. So if I also put this over 1, just to make that a fraction, because we also want to put this over the same denominator, then to make this a 10, I have to multiply by 5. But what I do at the top, I have to do at the bottom to keep it as an equivalent fraction. And then we multiply this by 2, top and bottom, and multiply by 10, multiply by 10. Okay, so now we've got them over the same denominator. So we'll have 5x over 10 equals to 2x over 10 plus 30 over 10. And then once we've got the same denominators, we can then drop the brackets. So then we could say, not the brackets, the fractions, drop the fractions, because it's the same as like multiplying every term by 10. So we'll have 5x equals to 2x plus 30. And then once we've done that, it's just a normal linear equation. So we'll take the 2x to the other side. So we've got 5x minus 2x equals to 30. And then we've got 3x equals to 30. And then divide both sides by 3. So x is equal to 10. Okay, so now that's like the one way. The other way just like kind of skips the step. Like from here to here, basically what we did, we multiplied each term with 10, which is the lowest common denominator. But if you just like start, from the beginning and take each term, multiply it by 10. So that's just a different option of how to do this. So instead of like putting them over the same denominator, multiply by 10, multiply by 10, multiply by 10, what then happens is this 2 goes into itself once, into 10 5 times. 5 goes into itself once, into 10 2 times, and that becomes 30. So if you want to do that, like that would also end up here, give you the same result, but sometimes people prefer, well, it's just a matter of preference. If you want to first just put everything over the same denominator and drop the denominators, do that. Or if you just want to go ahead and multiply each term with the lowest common denominator and then cancel, then you can do that. So, but I think majority of people might prefer putting it over the same denominator. So I'll just do this example like that. So we've got x plus 3 over, so 2 and 3. The lowest common denominator between 2 and 3 is 6. Okay, so I'll just put this over 1, this over 1. We can also just put both of these terms over 1, make this one term. Yeah, either way. So yeah, let me then just multiply by 3. So just remember, if you multiply by 3, it's important to put this in brackets because this is now seen as one term, and that 3 there needs to go to both the terms. Especially be careful when there's a negative in front of a fraction. That's where a lot of mistakes also happen. The negative actually has to go to the x and the minus 2. So that minus 2 is actually going to become a positive 2. So times by 2, and then here times by 6, times by 6, same here. Okay, now if we rewrite that, we have 3x plus 3 over 6 minus 2, x minus 2 over 6, and 6x over 6 minus 12x over 6. Okay, then when we simply drop that, drop the denominators, so you could also start multiplying out at this point. I'm just putting in all the steps. 6x minus 12x not x, that's a constant, sorry, that shouldn't be there. That's just 12. Multiplying that out, 3x plus 9 minus 2x plus 4 equals to 6x minus 12. Then all our x's, now it's just a normal linear equation, come to the one side, and then we have the constants on the other side. So this is x minus 6, that gives us minus 5x. This becomes negative 16, negative 25. Divide both sides by 5, we get x equals to 5. And that's done. Okay, and then the last one. So the final example, which has a variable, the int. So same story basically. There's just a small difference at the end. Now lowest common denominator would be x, which means we just multiply this term, top and bottom, with x, and we'll have all of that. I don't really have to rewrite all of this, but anyway, I've done it now. So if we drop those, we'll have 3x plus 10 equals to 2x plus 5, and then we just multiply out the bracket. So 3x plus 10 equals to 2x plus 10. We're still on the right track here. Yeah. Now let's bring this over. 3x equals 3x minus 2x equals to 10 minus 10, and x equals to 0. Okay, so our final answer is x equal to 0, but we just have to check. We know that if we have a fraction like 4 over 0, this is like undefined. We aren't allowed to have a 0 in the denominator, so this does actually not exist, so it's like no solution. So just always check if your answer to the x value will produce a fraction over 0, then you basically just end up and say no solution, because that solution can't exist. If you, for example, let's say it was like 2 over x minus 2 and your answer is 2. So let's say you solve for something that contains a fraction like this, and your final answer is 2. This, if I substitute 2 in there, I will have 2 minus 2, which is 2 over 0, which is not allowed, and then you'll just end up and say no solution. And yes, that's it.